use a laser and treat the metal surface, create a range of surface structures, and these structures alter a range of metal properties. So it's make a regular metal repel water and stay clean and also highly absorptive to light.
You've essentially created a super metal, a metal that repels water.
That's right.
What about the surface of the metal changes? What does the laser add or what does the laser take away on the surface of the metal?
We turn a smooth surface to become highly structured.
Kind of like an up and down wave structure, but on such a tiny, tiny level.
Yes, right. If you really zoom in with a high power microscope, you'll see the nanostructure like a little bit like a up and down, but at very tiny nanoscales. Those microstructures, they have what we'll call is a micro grooves on the surface.
So, what about this wave structure on the top of the surface means that the metal is now waterproof and it repels the water away?
When you have these structures, essentially metal surface does have interaction, attraction with the water molecules, and water molecules among themselves also attract to each other. So depends on the strength of the two attraction force. And those structures significantly reduce the interaction force between the metal surface and the water. The water molecules among themselves really bonded together comparably much stronger than this force between the metal surface and the water molecule. Essentially, so the water will stay in the droplet and beat up and repel away by the metal surface.
So, what applications can you see your new metals having?
Any applications that requires clean, dry, waterproof, I think will benefit from our surface. If you can repel water, you'll keep the metal rust free. The other application is it will also prevent the metal from having ice form on the metal surface. This can be useful for aircraft and also doesn't get contaminated with water and water containing waste or pathogens. I think it will have a lot of sanitation applications as well.
I can see this having a lot of applications, but what stage are you at with making this something that we can use in everyday life?
Yeah, at this stage, I think it's early on. This is quite new from our laboratory research, but we are working on scaling up and hopefully we'll apply this for real life applications soon.
You can waterproof metals at the moment. Can you see this technology being applied to other materials? So maybe phones and things? Because I'm thinking it'd be quite nice if we could repel all the water away from our phones or electronics.
Yeah, I do believe so. And we actually are working on creating this waterproofing property on other materials as well, including electrics and polymers. I do believe this property can be applied to other materials as well.